Alright, so problem 14 is mostly a review of collisions and projectile motion, but at this point in the year it's probably been a while since you've seen some of these in action. So I'm actually going to do all of that, and hopefully that rings some bells for you before the exam. But to start off with, we have a little bit of simple harmonic motion to help us find the mass. So first off, we got mass 1, which is, if you've read the problem, hopefully you've done that by now. Mass 1 is the block that's moving in and colliding with the block attached to the spring, which is mass 2. And we know that they give us this mass is 0.2 kilograms. Once it's collided, the period of oscillation of mass 2 is 0.14 seconds. The spring constant of the spring attached to mass 2 is 1208.5 newtons per meter. And the initial velocity of block 1 as it goes in, is that right? Yep, is 8 meters per second. And the height that block 1 falls after leaving the edge of the raised platform is 4.9 meters. So I believe those are all the givens in the problem. So let's do some simple harmonic motionizing quickly to figure out M2. So we got this relationship for period of a oscillator of a certain mass attached to a spring of a certain spring constant. And so this is going to be mass 2. So rearrange algebraically, and you get mass 2 equals T over 2 pi squared times K, and plug in all the givens, 0.14 and 1208.5, and you get 0.6 kilograms for the mass. Now it becomes, so that's all chapter 15 stuff. That's all of the chapter 15 stuff that's in this problem. The rest is review. So we get conservation of, this is an elastic collision, so we have conservation of momentum and kinetic energy. So we got M1, let's do momentum first. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. And we know all these. 0.28 plus 0, starts at rest, equals 0.2 times V1 final plus 0.6, which we just found up here, times V2 final. Then we have conservation of kinetic energy because it's elastic. So 1/2 M1 V1 squared plus, I'm just gonna, just to save a little space, I'm just gonna make this 0 because M2 starts at rest initially. So let's just do that right off, and that equals 1/2 M1 V1 final squared initial, excuse me, plus 1/2 M2 V2 final squared. Halves cancel, so we got 0.2 times 8 squared equals 0.2 v1 f squared plus 0.6 v2 f squared. So at this point it's algebra, and I'm going to skip all that. Basically I'm going to solve for v2f here, stick that into here, and solve for v1f. You get a quadratic, so there's two solutions. One of them is 8 meters per second, the other is -4 meters per second. We want this one because the block's going backwards, right? If you look at the picture on page 406, basically I've defined to the right as positive because of the 8 here. I made it positive 8, so left must be negative, so we need that guy right there. Now it's just projectile motion, so let's set up projectile motion stuff. X, Vx, t, everything else is 0 in the x direction because there are no horizontal forces. And we got y initial, y final, v y initial, vy final, a t. Whoa, whoa. And we're looking for D. That's this. So that's our main goal. We know now that the velocity in the x direction is 4. I'm just going to call it positive, because at this point with projectile motion it doesn't really matter whether we're going left or right. Let's start at a height of 0 and go down to a positive height of 4.9. And I just did that because I wanted to make gravity positive. So down is the positive direction, so our displacement must be positive. We start at rest because we're moving horizontally initially. In the y direction, no motion until you start falling. And then we don't need to worry about this. So let's find time using this column. We got delta y equals v initial, vy initial t plus 1/2 a t squared, 4.9 equals 0 plus 1/2 9.8 t squared. That gives us t equals 1. Yeah! Second. So we'll stick that here, stick it here, and then since there's no acceleration in the x direction, we got constant speed, so v equals d over t, or d equals vt, which is 4 times 1, or 4 meters. So it travels 4 meters in the x direction. Not too shabby. So a good little review of elastic collisions, conservation of momentum, conservation of kinetic energy with that, and then projectile motion. Remember to set up the two columns to organize your givens so that you know where to go. Alright, next video.